Hi, Vinay. Let's just wait for about 5 minutes and let's see if other participants join. Then we can start off today.
Sure, sure.
Okay. A very good evening to all of you. I hope you are aware of the topics that we will be covering. We'll be solving some competitive questions today under data structures and algorithms. So we'll have it session wise, like on various topics. Today, we'll be focusing on arrays and hashing. Okay, that will be the main focus about this. So the problems that we will be attempting, there are numerous ways to solve these problems, but we will be taking up the most efficient way. All right. So it's also there's a probability that you might get these questions as interview questions. So they are commonly asked. Like I have listed out questions here that can be like those are more probable when it comes to interviews. So usually these type of questions are encountered. And the thing that they'll be checking there mainly is not what is the, not that you can find a solution to these problems, but how efficient is that solution? That's what they'll be figuring out. Like, what's the time complexity? What's the space complexity? Is it competitive enough? Is it effective enough? Or is it going to be easy on the system to solve it? Is it going to take a shorter time? All of those, right? Obviously, there are multiple methods and they can be utilized. That's not the problem. But we'll be looking at the most efficient solutions. All right. And I'm assuming that all of y'all are going to be practicing along, right? Do y'all have your notebooks with y'all, as in the systems? Right? Okay, perfect. Vinay says yes. What about you, Rohini and Ashish? So you can either utilize Jupyter Notebook for executing the programs, or if you don't have Jupyter Notebook installed, you can go ahead with Google Colab. Okay. So yes, we'll be solving about 4 questions, 4 to 5, depending on what time permits. So one thing that we will be doing is we will first understand the question. Then you all are going to help me out, like what can be the possible approach. We'll discuss the approach. So after that, we will pick up the most efficient approach. We will go through that approach and also backtrace it, right? We are going to backtrace by taking some input. Let us try and understand how it was implemented so that you'll get an understanding of how the programming is working at the back end as well. Okay, I hope that sounds good. So let me share my screen and we can start off. Okay. So by the end of the session, I'll share the notebook with you all, but I would recommend that you also jot it down at your end, right? So that if you get errors, we can sort it out. I hope you all remember the concepts of DSA. Okay, the very first question that we are going to be looking at here is, it's famously called as the two-sum problem. Okay, it's addressed as a two-sum problem. So let me also give you the description of what exactly is a two-sum problem. Okay, I'll put up the question as well. Okay, so here's the question. So given an array of numbers, just happened here. So given an array of numbers that consists of integers, and we have a variable called as target variable. Okay, so we need to look for numbers in this list of, in this array of numbers. We need to look for our target variable and return the indices of the two numbers who add up to become the target variable. For example, if our target variable is 5 and we have a array of numbers. Now, in those numbers, which numbers can add up to give us our target variable, that is 5? Which are those numbers and what is their index value? To figure that out, that kind of problem is known as a two-sum problem. Okay, so in an array of numbers, we are going to figure out the sum of two numbers, and that sum of two numbers needs to match our target variable. All right, this is what is our two-sum problem. I hope the question is clear to you all. Any doubts here? Okay, now tell me, what can be the probable approach for this? What do you think can be done here? We have an array of numbers. We have a
So,
target variable.
like, if we have an array and we have numbers, right? In it, we
Yes,
have to select based on index, and then we have to add.
correct. Yes, based on index, and then we have to add. Okay, any special function that we will be utilizing here?
Concat, sorry, some based
Sum.
on integer and strings based on that.
Integer and strings. Okay. All right. So now we are also going to utilize the index numbers, right? So when we are always talking about index numbers, we are going to have a special function called as an inbuilt function called as enumerate. Can you all recollect what is enumerate? What does the enumerate function do? Okay, the function enumerate basically iterates in your loop. Okay, the first thing it does is it iterates in the loop. Iterate is nothing but the pointer points at the first element, then it moves on to the next element, next, and so on. Okay, it iterates. But along with that, it also stores your index value of those numbers. So in an array, you must be knowing, recollect your DSA topic of arrays. So every time in an array, we also store the index value, right? That's the advantage. So when we have your index value, according to our question here, it needs to return back the indices. So what happens? We cannot just give the array numbers that 3 plus 2 is giving us a 5. We cannot say that. We need to return back at what position or what is the index value for that 3 and 2 in your array. So for that, we are going to be using your enumerate function. Clear? So let us look at the program here first, and then we are going to backtrace it, like how exactly did we do it. Okay. Like always, we are going to take up a function. So I hope you remember what a function does. A function, it executes any piece of code and it performs a specific task. So here our task is to go through this array of integers that we have and figure out if any of the integers in it are going to give us are going to give us a sum that is going to be equivalent to the target. Okay, so now, first of all, let me create a function. So I am giving sum and I am mentioning I'm mentioning the function name as the to sum problem only. All right. And we have two things that are being passed. One is your nums, that is the integer, and the other one is your target. So these are the two things that we are asking your function to expect. So after the function expects this, now I am going to create, we need to follow an efficient way. So I can create a list also and keep throwing lists here, as in keep throwing your numbers in the list once your loop goes through it. But the problem here is we need the index value. So how do we have the index value along with the number from from your array? Any data structure that you can speak of in which we can store the value as well as store the index also? Any data structure that you all can recollect of? Yes, no. Is it a set? Is it a list? What kind of data structure can store a value and a key?
Dictionary.
Perfect, Subbalakshmi. A dictionary. So what we are going to be taking here is we will initialize an empty dictionary. Why? Because it is mandatory that we need the index value. They are asking us for indices. So that way we are going to initialize a dictionary. So I will mention num2 index. I am starting off a empty dictionary. All right. An empty dictionary is started. Now we have to go through your entire array element by element, right? But also index value is in picture. So what did I tell you? A special function that comes into picture here is your enumerate function. What does enumerate function do? It stores your array, it reads it as well as it stores the index value along with it. So I'm going to start my loop for I, and I'm going to say num in enumerate. So num in enumerate, that is each element from my nums is num and I'm enumerating it. That is going through my array nums and also reading its index value. Enumerate. What are we enumerating? My integers array named nums. Okay. So this is clear so far. Any doubts, please let me know. I'm explaining it line wise so that you all don't get confused at all. Now, after we have initialized this loop, now I have to go through my array. What is it going to do going through the array? It has to figure out the two numbers such that they add up to be my target, correct? So instead of finding what adds up to be the target, how exactly can we figure that out? I have a certain number. Now I want to figure out if it's going to give me the target or not. So one approach that we can utilize here is, can we figure out the complement of it? Can we take the complement? That is, we minus whatever number we have on hand, we subtract our target value from it. Then what it's going to give, we can store that in our dictionary and then try to find out if that is matching our target number or not. Does that make sense? If we figure out the complement, right? So now I'm taking the complement. In complement, what am I storing? I am going to subtract my number from this nums with the target value. So I am asking it to subtract the target value from whatever number it's encountered in my array. So once the subtraction is done, the difference is found out, I'm storing it in complement. Now I'm giving a condition. If my complement is present in this integer, in this dictionary which we stored, num2 index, in num2 index, if that number is found in this num2 index, then what are we going to do? We are going to return that value by saying what? We are going to return num2 index, that is the dictionary, whatever is stored in the dictionary, num2 index, we are going to return the complement of it, this complement which we are storing with the I value. What is our I value? I value is nothing but the index, right? It's going to return the index of it. Then we have num2 index, and we are num2 index, we have two things here. In a dictionary, what does it contain? It contains your key value pair. So we are telling for that particular number, give me the I value. I value is nothing but your index. So it stores the index of the current number that it's pointing to. Then we are going to, after this, we will just initialize what is the input. So now what was the input? It's expecting two things, nums and the target. So let us give both nums. Nums is equal to, I'm giving an array of my integers now. I can give 2, 7, 11. Some random integers you can give, right? 2, 7, 11, 15. Now target. I am telling target is equal to 9. So what do we figure out? We have to figure out which among these numbers will sum up to give us 9. So whichever numbers they are, their index value or I value needs to be returned to us. Okay. So we have told this. Now let us print. Let me call the function. What's the function? The function that we have given is toSum. So toSum, and in that we are calling two parameters, nums and target. We are passing two parameters. So let us print it now. Okay, so which are the two numbers that can give us a 9? So they are at position index value 0 and index value 1. That is 2 plus 7 can give us a 9. Okay, so now let us run it line wise. So what happens line wise here? So first of all, nums, it is our integer. Here you can see the array of integers. Then 9 is our target. It has to sum up to this number, and whatever numbers from this array sum up to this number, we have to return the index value or its address. Okay, so that's what we are telling here. For that, we initialized an empty dictionary. This num2 index, it is our dictionary here, right? We initialized an empty dictionary. What does the dictionary store? It stores numbers that you can see here as your key, numbers as the key, and whatever index value is associated with it, that is being stored as your value. So always a dictionary stores key value pairs. Key is the number from your array, and the value that it's storing is the index value of your number in that array. Okay. Now next what we are doing is, For I, we are running a for loop. We are running this for loop in your nums array for every number that exists by utilizing your enumerate function. So what does enumerate function do? It is going to list out all the numbers with both the index value as well as the number in these arrays. In this array, it's going to list out both the index value as well as the numbers. That's what this line does. It is running a for loop over it. Now, inside this for loop, we are telling for every number, find out the complement. What does this complement store? Simple thing. It's going to do your target. That is 9. 9 minus 2. It's going to figure out 9 minus 2. What are we getting here? 9 minus 2 would give us a 7, right? So we are storing this 7. Now, where are we storing this 7? We are storing it in the variable component. After that, we are going towards a if case. We are telling if this 7 exists in your dictionary num2 index. If it does exist, what are we going to do? We are going to identify the I value associated with it, and we are going to return that I value. Okay, so 7, it does exist. What is the index value associated with it? It is 1. The index value is returned, that is 1 is returned here. So it returns a list containing the index of the complement and the index of the current number as well. So this I, it returns the index value, that is this 1 it's returning, and also the number associated with it, right? And the current particular number that it's pointing to, that also we will get to know. Now, currently it is pointing to 7. Next, again, it's going to go back, figure out the next complement, next number we are going to take. Then next two numbers we will take, and we will figure out if target minus 7. What is target minus 7? 9 minus 7 is giving us a, what is 9 minus 7 giving us? It's going to give us a 2, right? So again, it's going to look for 2 in this. So in this 2, what is our what is the index value for the complement? It is 0. So it returns back 0 and 1. So both are being returned. Now, in case it is not found, let's do the next one. 11 minus 9 minus 11. 9 minus 11 would be minus 2, right? So does minus 2 exist in this array of yours? It doesn't exist. Then what does it do? It just comes out of the loop. So this for loop, it comes out of this for loop entirely, and nothing is printed. It will only print what numbers exist in this particular array of yours. Is this clear? Any doubts here? Please let me know if anyone hasn't understood the working. Is the backtracking of the program clear to you all? Anyone who wants me to repeat it? Okay. All right, good. Subbalakshmi wants the code. All right. There you go. Okay, then no doubt, right? Fine. Let's move on to the next question then. So the next question that we have here, it is to check if there are any duplicates in the array. Okay, we are going to check if any duplicates exist in the array. So what approach can we take? We have an array and we need to check if there are any duplicates. Simple thought process. What can we do? Tell me quickly. Okay. So before we move on to the next question, let us also discuss like what is the time complexity that we are encountering here. What is the time complexity in this? So here you can see that we are running a for loop, right? So now the dictionary for loop is being run, but along with that, what is the other thing that we are storing our index value in? We are storing the index value in a data structure dictionary. So what is the advantage of storing using our values in the data structure dictionary is that it allows you to look up any number of times, and the time taken is always constant. Whenever it searches for any value in our dictionary, the time it takes is always going to be constant. So what you have here is you will always have the time complexity as O(n). O of the order n. That is how many ever times you are searching this dictionary. For example, if it takes 1 second to search one element in your dictionary, then if you search 10 elements in the dictionary, what happens? It is going to take 10 seconds. So that means whatever is the value of n, the order is going to be order of n. That means it will take so many seconds depending on the number of iterations. Simple. So that is your time complexity. Hence, the efficiency, since it's O to the order of n, our efficiency is very good for this particular program. Understood why we took up this method? Okay, so if we would have used a brute force method, what do you mean by brute force method? Brute force method is instead of storing it in the dictionary, every time you give the number, I am going to search it through my entire array every single time. I will try to add it with all the numbers in my array and try to figure out a pair which matches this, and then simultaneously go look for its index values. So what is it doing? It is first of all, as soon as I get the number on hand, it starts searching the entire array. After it searches the entire array, again it will go and reiterate through the entire array to find out my index value. So it is doing this repeatedly for the entire array. So what happens? That kind of approach is called as a brute force approach. Now in the brute force approach, every time we enter the loop, we are doing the number of searches. For example, if we have 5 values, so I have one number on hand. So when I get this one number on hand, I will search it 5 times. Next, after searching it for 5 times, if I find a number, okay. If I don't find a number, again I go back and take another number from my array, come back and search this entire array again. There is no starting point that's defined. I'm doing this repeatedly. So that becomes as n square. That is, every iteration, my n value keeps increasing. So that is known as order of n square. That is, it will take n square amount of time. Whereas in this approach, it is taking n amount of time. So it's order of n and order of n square. Okay, that's the difference between taking up a dictionary, a effective data structure algorithm, an effective data structure, or else if you go with brute force, then that is going to enhance your time complexity as well as your space complexity. So I hope that you understand what is brute force, right? So in case you have not understood what is brute force, then let me give you an example here, that in case you enter a street, okay, in that street, the address given to you is come to 5th cross. Now, you can either go into every cross that you see and check if it is the 5th cross. That is your brute force approach. Else, you can calculate in your mind, I just entered the street. The first lane here cannot be the 5th cross. Maybe the 3rd or the 4th lane can be the 5th cross. So let me go and check the 3rd or the 4th lane first. And then based on that, I can reiterate where to go. So that kind of approach is an efficient approach. So whenever we use an efficient data structure, it gives us an efficient time complexity. Clear? Okay. Next, we are going to check.
In case if we have a repetitive, like you said 2 comma 7, 11 comma 15, right? Later if we have 1 comma 8.
Okay. 1,8. Now, if this also adds up, you're telling me, right? So then what it does is the very first thing it's going to pick up here, we are telling return indices of the two numbers such that they add up to the target. So we are only asking it to pick the two numbers. So what it does is the first encounter it's going to pick up. It's not going to go through with your rest of the list. As soon as it encounters it, it is going to pick it up and go ahead.
Yeah, got it. Thank you.
Sure. Okay, so the next thing we were doing is check if our array contains any duplicates. All right. So when we are talking about this approach is pretty straightforward. There is nothing much to do here. So here there are two options. One is the most common thought that might come into your mind is why not use a list, right? Use a list, store the numbers. If the numbers are having any duplicates, then after comparing both the lists, if any duplicate exists, it will flag it, right? We are just going to print that true duplicate exists. But what happens if we use a list? If we use a list, the time complexity increases. Now, why does it increase? Every time you start looking for something in the list, you have to go over each element to check if it exists or not. Whereas if we use some data structure like dictionary or hash maps or sets, what happens is we have a key value pair that is associated with every entry in our array. So with every entry, we have the key value pair. And once you figure out what is the key value pair for this particular thing, it is not going to revisit your array every time. It is just going to look up your dictionary or look up your set or your hash map. Okay, once it looks into it, it is just going to take once the same constant time for every lookup. It's not going to increase the time. The time is constant for every lookup that it will do, either in your dictionary or in your hash map or in your set, whatever those kind of data structures are. Whereas in your list, what happens? Every time you give a new entry, it's going to go search your list again and again. Every element of the list it's going to search. But that does not happen in your efficient data structures like your dictionary or your map or your hash map or your set. So here, I will show you both the approaches, but this actually plays a role when your list is huge. Imagine a use case where you are looking at an inventory of items. Okay. So if you are uploading something on the e-commerce site, you have a huge inventory of items to be uploaded. Now, if there is a duplication there, then it's a problem. If there is some category that is being entered twice, then it's a major problem, right? You're re-entering everything twice for it. So to figure out such kind of duplications, you can run such a program. But the thing is, if we do not take up a efficient way, then it's going to take a huge time. You have to run the program and sit and wait for it. But if you take an efficient data structure, it's going to happen, the same is going to happen at a very efficient pace. So let's look at both the things. So I will show you both. So now we have a function here. So I will just name the function contains duplicate, and in that I am passing my array nums. All right. So once the array is passed, I will create a variable named as scene. Now in this, I will pass my list. Okay. I am giving an empty list here. All right. So after I have initialized an empty list, I will run my for loop for num in my nums array. What I'm telling is, if my num is available in the scene, what does scene contain? Scene contains my list. So if it's available in scene, then I will say true. That means duplication exists. Else, after that, after the duplication we are going to update the list now. So I am saying scene dot append. How do we update the list? Append, and we are adding num here. After that, in case it is the number is added to our list here, but in case it's not available, that number is not available there, then we are going to return false. That means no duplication here. Okay. Now this is going to be the program. Simple check, right? So now let us create your nums array here. So I'm giving 1, 2, 4, 2, 1, 3, 5, 6. Okay. So I'm giving so many elements. And now let me just call your function. Let me give the print command here only. Print, and your function is contain dupe. And then I am mentioning my list here directly. Let me just call it Okay, I'm mentioning the list here. Contain these capital. Okay. All right, let's do this.
S is missing.
Sorry. Yeah. Thank you. Okay, so here we are getting to know that yes, duplication exists. It's clearly visible, right? But when our list is long, the time it's taking here is every time it is iterating towards every element. It will check all of your elements here to figure that out. Now, the efficient way is instead of declaring it as a list, instead of having that scene as a list, we can declare this as a set. How does set function in data structures? It will work exactly like your dictionary, a hash map. Okay, so it is going to store both key value pairs then. So we are going to initialize an empty set. Then after initializing the set, we are going to, instead of append in set, we have the method add. Okay, we are adding your numbers here. So the same thing, but the only difference is our data structure has changed. And this is going to be, it is just going to look up your elements here. In your key value pairs, you have already stored it. It will give one look to your hash table. It finds the duplicate and that's it. It's just going to give the value, return value as true. It's not going to go look up every single element. Got it? Do you understand the difference between the time complexities here? Any difficulty, please let me know. Okay. If this is clear, then we can move on to the next one. I've shared the code. So in the same way, we can have another one where we don't have duplicates and it's going to, so let's remove the rest. Okay, you can see false. So I'm just covering up both the cases. Okay, next program that we can have here is, okay, we can look at intersection of two arrays. We'll have two separate arrays and we need to figure out at what particular element is there an intersection between two arrays. Okay, so each element in the result that we are going to create, it should be unique and it must return the result. It can return the result in any order, but it must only contain the unique element like from that particular list, and the same needs to be present in the other list also. It needs to be an intersection of both the lists. Okay, so let me have it as intersection. Intersection of two arrays. All right. So intersection of two arrays, what do you think we need to have? Obviously, we'll take two arrays as inputs, right? So after we take two arrays, again, utilize a data structure in such a manner that it is efficient. So far, what have we learned? Your dictionaries are efficient, your sets are efficient, your hash maps are efficient, right? So all of these sets or dictionaries, they play the role of a hash map. Fine. So now let us again go with an efficient data structure here. So I'm creating a class called as solution. So what are we going to do here? What is the approach that we use? Anyone who can speak about the approach? Okay, so here what we are going to do is we will have two integers. Obviously, we'll have like num1 and num2, two separate list of integers. After that, we are going to inform that we are going to expect the input in the form of a list because we are declaring two lists of integers here, right? And then the output, it has to be again sent back in the form of a list only. So we will have your like sets again here. Why sets are going to be utilized? Because it is efficient in your lookup, your time complexity again, order of 1. Why? Because it is going to take the same amount of time, how many number of elements are existing. If it takes 1 second for one element, then for 5 elements, it's going to take 5 seconds. So it's going to be order of n. So let us go through that now. Okay, since I told you that we will have it in list and we need to make sure that it is converted back to list in the middle, whatever working is going to happen, that is going to happen with an efficient data structure. So now let's create a function called as intersection. Okay, in this, I am going to pass your lists. So first of all, I am passing self and now num1. This is one list that I'm creating. So list, I'm informing it that expect a list and it is going to be in integer format. I'm also giving the data type for it. Then I'm telling num2. Num2 will also be of list type and it's going to be of the data type integers. Okay. Now both of this, they need to be implemented in the form of a list. Okay, this is our declaration for a list. Now after this, what do we need to do? I told you an efficient data structure has to be utilized. So what is our efficient data structure? I am calling my set again. So I am converting it to a set. So num1, whatever list we had, I'm moving it to a set data type and storing it in the variable n1. So after this, whatever result we are getting, let's put it in the form of a list again. Now the comparison starts. We need to find where the both the elements are matching, right? What is that intersection point? So we need to compare both. So I am declaring a for loop for n in num2. Let's take the second array. If your n value is in n1, what is n1? n1 is our set. What does the set contain? Key value pairs. What are our key value pairs? It consists of the number as well as its index value, right? For n in n1. So in case the n value from your num2 exists in num1, then we are just going to, this is a list, right? So this is not a set. We have declared this as a list, the result. So what do? We append or add. For our list, we have the method append, right? We are going to append the value, whatever we found the match as. Now, in case it's matched, then what will we do? We are going to remove it from here because we are trying to find out unique values, right? We don't want duplicates. So once it's found, I am removing it from this set. So n1 dot remove whatever value we found, n. Okay, whatever value we already found here, we add it to your result and we are removing it from the set. After we remove it, I'm going to return back my result. Now, what is my result? In which format it is? It is in my format of the return my result. Okay. Okay, once this is returned, now I need to run my solution. Where I'm storing the solution, I'm running my function here, solution. And after that, let me declare my num1. I'm giving a list here. So 1, 2, 2, 1. Okay. And num2. You can see there's a duplication that existing here. And in the second list, let me give 2, 2, 3. All right. Now I will say the result is equal to, I'll call my function. So what is my function here? It is solution dot, inside that I've given another function intersection. Intersection. Okay, intersection. And what is it expecting? It's expecting two lists, num1, comma, num2. Okay, two lists it's expecting. Let me just print my result. Let's go with it. Oh, what did it do? Class solution. It is taking intersection. It took myself, then num1, it's taking list. Num2 again, it's taking list. And then int. List is not defined. All right, so I have to import it. What exactly is the class here? One class has to be imported here.
You didn't like mentioned num2. Only for num1 you mentioned it, right, in script. N1 equal to set of num1 and
No, set is fine. Here the problem is it's telling list is not defined. So for this, we need to basically include
oh,
or import your list here. So when we get that, we have to import your list. Now for that list, it is type function, I guess. So the type function we have not included. So from typing, that's your library, import list. So it's not able to create list because we have not imported the library. Now it should work. Hmm. It is. I've given num1, I've given num2. Intersection, it's not able to figure out. What are we going wrong? Somewhere we are facing a warning here. Num2. Intersection. Okay. Return result here. Is missing. What is that something? Wait, so we have the indentation for this here. Then we are starting off with your for loop for n in num2. Then we have your if case. Inside that we are doing these two. And then we are returning your result. Then we have your solution. The indentation here. Okay, here my for the return was not being returned by for, it was returning by if. My indentation there was wrong. Okay, so what's happened here? Here, what is the common point where they are intersecting? It is at the element 2, right? So in case I give the element as 4 and make it as 6, 4, 3. Then the intersection element becomes 4. Basically, whatever is unique in the other one, it should not be duplicated. Then that intersection point is going to be given. Clear? So whenever we are creating list, remember that you have to import the library, else it's not going to work. So that's one thing that has to be remembered. So now let us go over this by taking a number here, right? How exactly did this work now? Okay. All right. So let me have 1, 2, 2, 1, and then we had 2 and 2, right? So let's take this example only. So what happened here? So here, when we convert your, first of all, we started off as a list, correct? So once we started off a list, the first thing we did was we converted it to a set. So this particular element was converted to a set. So once it was converted, what happened now? Now it is stored in the form of set as empty set. So it's converted it to an empty set, and now we have an empty set here. So we have 1, 2, everything is given as a set element. Now we have initialized result as an empty list. This is a list. So inside this list, we are going to iterate through your num2. Okay, for n in num2. So what is the first element for 2? So n is equal to 2. So is it present in this particular set? Is this present in 1, 2, 2, and 1? Yes, it is present. So once it finds out, it's going to add to the result 2. It's going to add here. What is it telling? If it is present, then result dot append the value of n. And then what it does, it removes it from here. Okay, it's removing it from here. Then once it removes it from here, again, it is going to search. So is n like when it removes, it's removing the element 2, right? So both the elements are going to be removed. Now, after it searches again, does it exist? No, it doesn't exist. So what is the answer? It is only n. Then it will return the result, that is it's giving back 2, and it stops. Clear? Any doubts here? All right, so this is one. Then next that we are going to be working on is intersection is done. After intersection, we have some key. Let me share this with you. There you go. That's the code. Please let me know if you all are not understanding any part of it, anywhere where you are not understanding the back tracing or anything as such. Okay. Now what we are going to do is, this is slightly complex, this particular program, which we are attempting. The past ones, like it was of easy scenario, right? So this is slightly complicated. So now we are going to figure out a sub-array sum equals k. So this is the kind of problem that most of the interviews where it's asked. So it's a sub-array problem. Sub-array sum equals k, as in what we do here is we have an array, okay, a huge array, consider a huge array. In that array, then along with this array, we have a target like thing, okay, we have a k value. Now that k value can be, for example, 4, okay, k is equal to 4. We have a huge array and we have a k value 4. Now what we need to find out is, what does this sub-array sum equals k mean? In this huge array, we need to figure out subsets of this huge array which sum up to our k value. Okay, we need to figure out the huge sets which either give us the difference, basically not sum up, it's the difference, right? We take the difference that equals to k. Understood? Any doubts? What does sub-array mean? It is a subset of your array. All right. For that, now let me explain it to you in the form of, first we'll write the code, we'll run it, and we will backtrack it entirely with the help of a table, because this gets a little complicated. You might not understand if I just backtrace it with annotation, right? So, okay, let's start off. Let's have a solution class. Okay, in the solution class, I am creating a function. I am saying subarray sum. Subarray sum. Okay, in this subarray sum, I am having list of my array is in the form of a list. So I am giving self and I'm mentioning nums, which is in the form of list and it's of integer type. And then I have my k value that is also of integer type. Okay, it's a single number. Now this we are mentioning that we have your integers here. Int. Okay, here this full stop has to. All right. So far, what we did is we have given your k value is int. Sub array sum we are taking, self nums we have declared as your list int. K is also int. All right. So now because we are taking list, what are we supposed to import? We are supposed to import your type, right? From typing, import your list. Okay. So after taking the solution, then now we need your various variables. So what we need is we need your count. Okay, count is going to keep a track of how many subsets we have, subarrays we have that are equivalent to your value k. Okay, so we will initialize it to 0. Then I am taking your sum prefix. So, or we can take prefix sum. Prefix sum. Now, what does this prefix sum do? Prefix sum is nothing but your cumulative sum of your array. What do you mean by cumulative sum? At this particular time, whatever array element I am pointing to, the sum of the array element until then. That is, if I have an array like 1, 5, 6, 2. Okay. And currently I am pointing out to number 6. So what is my prefix sum? Prefix sum is my cumulative sum. That means 1 plus 5 plus 6. Whatever elements are occurring before that particular number, a sum of all that will be my prefix sum. Understood? Any doubts with what prefix sum is here in this particular program? Okay. So I'm initializing count to 0. I'm initializing my prefix sum to 0. Now I am initializing other thing called as prefix sum count. Now what is this prefix sum count? My prefix sum count is going to keep a count of my sub arrays which are getting equivalent to my k value. Okay, I'm initializing that as a dictionary. I am saying 0 element and it holds 1. Okay, the element is 0 and it holds 1. So now let me initialize it to this. So with prefix sum 0, the count is 1. That is 1 time 0 is present in my prefix sum because I have initialized it to 0, right? So how many times 0 is present? It is present 1 time. So what does this key value pair represent? My first key is the element itself. What is the element? The number, I mean. And the second, the value that it holds is how many times that number is present in my prefix sum. So it is present only once, 0 is only present once. So it's giving 0 is to 1, 0:1. All right. Any difficulty in understanding so far? Please let me know. All right. After we do this initialization, now we are going to run our entire, we are going to look for the numbers in your list num now. Okay. So we are going to iterate it. So I'm going to say for num in nums. Okay. For every number in my nums list, I am going to ask for the prefix sum. Prefix sum. What have we initialized prefix sum to? We have initialized it to 0. So prefix sum is going to be plus equal to num. What did I tell you? What is prefix sum? Prefix sum is my cumulative value of the array elements, right? So if my array elements have 1, 3, 5, 4. So if these are my array elements, so first I've initialized it to 0, then it is pointing at 1. So what is my prefix sum then? It is 1 only. Next, it points out to 3. What is my prefix sum then? 3 plus 1. So that's what we are telling. Prefix sum is plus equal to num, right? That means it is going to add up all values before that. Any doubts? with my prefix sum, right? That's what we did with your prefix sum. We are taking a cumulative number, a cumulative sum of it. Next, after we have taken this, now we are going to increment your count. To increment your count, I am saying if my prefix sum, whatever prefix sum we have found out, the cumulative value, if it is subtracted with your k value, I had told you, assume some k value 4. If it's subtracted from my k value and it gives some number which is equivalent to your k value. For example, whatever answer you are giving, it's 4, right? K value is 4. If it's equivalent to your k value 4, then what we will do, we will increase your prefix sum count. That means we are telling we found one subset where it is totaling up to your k value. So we will increase the prefix sum count. So if this sum value, whatever we are receiving, 4 is in the sum count, then we are going to increment your count. How are we going to increment your count? Count plus is equal to, we are incrementing your prefix sum count. We are incrementing it with the value of your prefix sum minus k, whatever value it's giving, after subtracting it with the k value, whatever value you're getting, you are increasing your count variable with that. So earlier it was 0. Then if whenever we have whatever difference we have received, we are going to increment it with that difference. Okay. Once this is done, incrementing the count, then we are going to update the frequency of our current prefix. How many times we have found this? We have to update it, right? Whether we found the 0 once, or we found the 0 twice, or we found 0 thrice, or we found some new number. So if we have found some new number, we are going to add it to our count. For example, if we found 2, then what will it become? 2:1. That means number 2 was found only once in your list. Okay. So if prefix sum in your prefix sum count, if it's present in your sum count, then what we are going to do? We are simply going to add 1 to it. That is incrementation, right? Prefix sum count, prefix sum, we are just going to add +1 to it. Prefix underscore sum plus equal to 1. Just adding, simple addition. Else, if it is not found, then what do? We are going to just add it as a new number altogether. So prefix underscore sum underscore count, we are going to add whatever prefix sum we found, prefix sum we found, and we are going to give it as equivalent to 1. That is :1. That is if we find out number 2 now. If we are not finding number 0 again, instead we found out number 2. So what will it be? 0:1, comma, what is the number we found? We found 2, but it's not existing in our list. So it will be 2:1. Now again, if we encounter 0, what will it become? 0:2. New number is not added. But instead of finding 0 again, we found some other number, like for example 4. Then 4:1. Why? Because it's not existing in our prefix count. It is a new number. That's why we will add it with 1. Understood? Any doubts? Please let me know if you're not understanding. We will again backtrace it. Don't worry. Okay. So if all this is not happening, then I am going to return count. After all this is done, just return your count. Whatever number we have received, we are going to return it. Now let me create my nums. That is 1, -1, and 2. I'm giving a very simple array here. And then I'm giving k value as 1. Okay. Then solution is equal to solution. I'm calling my function here And then I'm going to give result is equal to calling the function dot sub array sum. And what are the two values it's expecting? Nums comma k. And then just print the result. So how many sets can we have here? We have two sub-arrays which are equivalent to 1. So can you tell me which are those two sub-arrays? Anyone? If I have this array 1, -1 and 2, what combinations can sum up to 1 for me? Anyone? Okay, one element can be 2 minus 1. This gives us a 1, right? It's giving us the k value. The other one, what can it be? It can just be 1, right? So if we just take the element 1, that is also a sub-array. So it is giving us two arrays, which will give us the k value 1. Okay, so for this, let me create a table. Let me explain it with the help of a table. Okay. Now here we are taking 1, -1 and 2 as our array elements, right? First thing that we are doing is initialization. What are we doing? We are initializing everything. So when we are initializing, what are we initializing it to? Init, right? We are setting your prefix sum to 0. Okay, we have set it to 0. Then we set your count to 0. Okay, then we set your prefix sum count to 0 colon 1. These are the three things that we have set. So if you can see here, this is the first statement that we have made here, right? So what are the declarations? We have told count is equal to 0, prefix sum is equal to 0, and then prefix sum count is equal to 0 comma colon. That is, number 0 has occurred one time. Okay, this is what we have initialized with. So the step init is our initialization step. Okay, any confusion with our initializing step? All clear, right? Initializing is clear. Now don't worry about this prefix sum count after update and before update. Just look at before update. I will explain after update. Just look at before update. So far we have done this. Now next step, step number 1. Okay, initialization step is done. Now iteration number 1. What is the first number in our array here? First number is 1. So we are taking 1. What did I tell you prefix sum is? Prefix sum is our cumulative sum. Cumulative sum as in it is taking my element. It's taking 0 plus 1. 0 plus 1 is what? It's giving me 1. So my prefix sum is 1. So 1. Now prefix sum minus k. What is my k value? It is 2. So 1, 2, 1 minus 2. This prefix sum minus my k value. So 1 minus 2 is minus 1. So it's giving me minus 1 here. After getting minus 1, now let us look at the prefix sum count before it has updated. Updating has not happened. So we are retaining it as it is. That is 0, number 0 has occurred only one time. Okay. Now minus 1. Does your prefix sum count exist? Does it exist in your prefix sum count? Is minus 1 present here? Not present, right? So it is a no. Then our count remains 0 as it is. Okay. Now we have encountered a new number here. That is 1. What is our prefix sum that we have encountered? 1. Now 1 is not there here. 0 was there. So what did we do? 0 colon 1. We already know that 0 is occurring one time. Now we have a new number prefix sum 1. So 1, how many times is it appearing? It is appearing only one time. Okay, so we have added prefix sum count. We have incremented by adding the number, new number which we encountered. How many times is it occurring? We have added. Next number we will introduce. Next number, what is the next number? Again 1. So we are in the second iteration, we are introducing again the second number of your array, 1. Now prefix sum is a cumulative sum. So 0 plus 1 plus 1. So how much is it? It is going to be 2. What are you introducing to your prefix sum? It is 2. Now 2 minus 2, k value, right? Prefix sum minus k. 2 minus 2 is 0. Now what was our previous count? It was 0 is to 1, then 1 colon 1, right? Here, whatever. We have not updated. Now is this number, prefix sum minus k, is it found in your sum count? Yes, it is found. Now after, 2, is it found in your sum count? Yes, it is found. So what we are doing, we are increasing it by 1. 0 plus 1, right? So here that number is present. So we are adding 0 plus 1. So now we already have 0 and 1. We already had 1 one time. Now this number 2 was not there. So what we added? We added 2 colon 1 time. Clear? Any doubts? So far, any doubts? Because 0 existed in your sum, we incremented it with 1. Next, what are we introducing? We are introducing the last and the final element from your array, that is again 1. So I am calling again 1. This is the last iteration. So cumulative sum, 1 plus 1 plus 1. How much we are getting? 3. Prefix sum is 3 now. 3 minus 2 is 1. We have got the answer as 1. Now this has not been updated. We are taking the same 0 colon 1, 1 colon 1, 2 colon 1. This is the count. But is 1 present in our array? It's present, right? Yes. So what do? We add plus 1 to it. So 1 plus 1 is 2. And what is the number that we are having in prefix sum? It's a new number, right? So 3 colon, how many times it's appearing? It's appearing 1 time. So 3 colon 1. This is how we are updating the count. Any difficulty in understanding this? Okay. If there is no difficulty here, then I will take another example here altogether. Okay. Let's take up the example of, we took 111 now, right? Okay. Let's take one more example. 1 minus 1. One minus 1 and 2. Okay. And then this k is equal to 1. Now this is the question here. Let me change it here. 1 minus 1, 2 and k is equal to 1. This is the one that we are looking at, right? So here, let us do it. Let's look at the questions here and go ahead with it. So first thing, what is it telling? Initializing step. Let us initialize it. So let me initialize it. What are we initializing it to? We are initializing it to 0 count, prefix sum 0, and then we have initialized sum cost to 0 colon 1. That is 0 has occurred 1 time. So first step is done. Initializing it here, and this initializing step is clear. Next step, what we are doing, we are telling for every number in nums, that is for these number in nums, for 1, minus 1 and 2. For num in nums as in it's taking the first number, first iteration, first number. So first number, what we are telling, prefix sum plus equal to num. That is cumulative sum of your numbers. So earlier what we had 0. 0 plus 1, what are we going to get? We are going to get 1. So here prefix sum, what have we entered? We have entered prefix sum as 1. Next, after that, what is the next line it's telling? It's telling if prefix sum minus k. What is our k value? 1. Prefix sum was 1. 1 minus 1. What is the value? It gives us 0. So if 0 is in prefix sum count, okay, 0 is in prefix sum count. Yes, 0 is in prefix sum count. Then what are we going to do? 0 is in prefix sum count. So what are we going to do? We are going to increment it. Count plus is equal to, what are we doing? Count plus is equal to, that means we are incrementing your count. What are we incrementing your count with? Prefix sum minus k. Whatever value we have received in prefix sum minus k, we are incrementing it with that value. So what we had? Yes, we found it. So 0 plus 1 is 1. And then whatever we have in the prefix value, we are going to update it. So 0:1, now we are going to get 1:1. That means number 1 is occurring only one time. Okay, so this is done. We have given if prefix sum in prefix sum count, then we are incrementing it by 1. Else we would have just kept it as 1, right? But we incremented it because it was present. Okay, we have incremented. Now again, for the next element, that is minus 1. So now when minus 1 is there, what do we do? Prefix sum plus or equal to number. That is, earlier we had 0, we had 1, and now we have minus 1. So 1 minus 1, how much would it be? It would give us a 0. So prefix sum is 0. And now 1 minus 1, what is it going to give us? Prefix sum minus k. So minus, we actually have 1 minus of minus 1, right? So what are we going to get here? So it is going to be minus 1 will be your answer here. Prefix sum minus k, right? So after we get this answer, we are going to look for before updation. This remains as it is here. So does minus 1 exist in this? No, it does not exist. So no incrementation. It just says 1:1. Okay. Next, third iteration, it's taking number 2. Number 2, and we are going to add all of these. So when we add this, 1 minus 1 and plus 2, we are going to get 2 here. So 2 is our prefix sum. 2 minus 1 is 1. Now, does 1 exist in your prefix count? It does exist. How many times it's existing? It exists one time. So what do we have to change it to? 1:1. It becomes, sorry, here 0, right? 0. 0 is prefix sum. It does exist. So that's why we are changing your 0 value to 2. How many times 0 is occurring? It's occurring 2 times. So that's why we have changed it to 2. And now here new number is being introduced, that is 2. 2:1. 2 is occurring only one time. So 2:1. Any doubts here how the backtracking is happening? If anyone has not understood this, this is a very crucial problem. Most of the times it's a very famous problem actually. So most of the times you do get a chance where they can just write a problem for sub array sum equals k, right? It's a quite famous one in your interview section. So I am forwarding this to you as well. Please let me know if there are any doubts. I am happy to solve that for you. Did you all understand the backtracking? Yes, no, maybe. Okay, fine. Now tell me, is this difficulty level of the questions fine with y'all, or shall I increase it a little more from the next session? How are you finding the questions? Shall we increase it a little more? Would it be better? Or do y'all want this same pace to be maintained? Are you understanding them, the solutions, the approach? Yes, guys, it would be great if you all can give me any feedback. Reason being that I can probably tweak your next session according to that, right? So if you all want any change, if you haven't understood anything, then it would be great if you all can just let me know, right? Or if everything was fine, you can we can maintain the same pace and have the same understanding. Okay, from next session onwards, I would be giving your two questions as your assignment problem also. So y'all are going to try that out. And in case y'all are not able to solve it at all, we will discuss that in the beginning or first 15 minutes in the beginning of the session and then start off with the session. So since today it was your first session, just touch base on all of your topics of DSA, recollect them because I don't want y'all to have a confusion with the topics and then not understand these, right? So just go through these topics again, wherein you have pointers, hashing trees, search, sort, all of these, so that when we are attempting these competitive questions, you're able to recollect the concept and go ahead with it. Right? So let me share this particular file with y'all. I am putting it in the chat box. All right. Okay. I'm not able to share the file. I'll send it. I'll ask the admin of your group to send it there. Okay. I'll share it with them. Does that work? All right. So any doubts, do let me know, guys. So we have last about 6 minutes of the session remaining. So I open it to any kind of questions, doubts. So the floor is open. Go ahead. Let me know if there are any additional things that you all want, or is the space fine, or any doubts with the session. Please let me know. Yes, Ashish, Rohini, Subalakshmi, did you all understand the questions taken up? All right. Okay. So the backtracking is also clear, right? How exactly you can recreate them, how the solution came up. Perfect. Thank you, Subbalakshmi, for answering that. All right, guys, if we do not have any questions, then we will be ending the session here. Thanks a lot for joining the session. It was a great pleasure teaching all of you all again. So we'll get back in the next session with the next topic that would be two-pointer technique, right? We are going to be using the two-pointer technique. So please go through that particular topic, that is pointers, so that you all have the pointers in mind and we can solve the questions. Okay. So until then, all the best. Please do your revision and we will meet up again on Thursday, same time. Okay. Thanks a lot for joining the session.